In August 2014, a paper was published in the specialized press that drew little public attention among a barrage of tragic news on street shootings, civil wars, and genocides. This scientific paper explained a feat of the nuclear industry, the distillation for the first time on planet Earth of a nanoscopic quantity of strangelet at Brookhaven's relativistic heavy ion collider. A strangelet is a substance made of liquid quarks, which is the most powerful explosive in the universe. Physicists believe liquid quarks have fueled the Big Bang, as well as other cosmic catastrophes like quasars, the Big Bang of galaxies, supernovas, the Big Bang of stars, and Ice-9 reactions, the Big Bang of planets. Why do quarks have such destructive power? Because the universe is made like a game of Russian dolls. What we see, the external cover, is mostly a bubble of empty space. But the last tiny Russian doll, which is made of quarks, occupies the nuclei of our atoms and is pure, solid matter. According to Einstein's equivalence between energy and mass, quarks contain 99% of the mass energy on planet Earth. If all the planetary quarks were to transform their 99% of mass into pure energy, it would lead to a Big Bang explosion equivalent to the most powerful explosions in the known universe.
Gravity is the dominant force in the universe. This tenet of Einstein's was irrefutable.
In 1939, Einstein discussed what would happen when a large amount of matter was concentrated in a small region.
Einstein wondered, could its gravitational collapse crush its vast quantities of matter into the tiniest of points?
In early 1964, Gell-Mann proposes to the world the existence of three new fundamental entities he calls quarks. They're more like little planetary systems. All the positive charge and virtually all the mass is concentrated in a tiny nucleus.
Now, what are the quarks? Are they actually real objects? Well, my experimental friends are making a search for them in all sorts of places. One atomic spectroscopist friend of mine calls me up sometimes at midnight to report his progress in a search for quarks in seawater. Most things with curious chemical behavior in the ocean end up eaten by oysters. And so now he's grinding up oysters and looking for the atomic levels in the oysters. So far, though, no quarks.
His three quarks could combine in different ways to reproduce the properties of this enormous particle zoo. It would simplify, organize, predict. It was a great scientific advance.
When Murray Gell-Mann's three hypothesized quarks were finally found, humans learned that they were made of the two lightest ones, the up and down quark, which combine in triads to form the protons and neutrons that make up all the atomic nuclei of our planet.
If the outer boundary of a hydrogen atom, where the electron is found, were enlarged to be 2 miles wide, about the size of a city, the single proton in its nucleus would be the size of a golf ball. It's here we find elements at their most elemental, because every nucleus contains protons, and it's the number of protons that determines what kind of element the atom is. The number of protons is called the atomic number, and it's the fundamental organizing principle of every table of the elements.
All the other heavier particles in the universe contain the third strange quark, which has 15 times more mass energy than the sum of our lighter up and down quarks. Strange quarks do not exist naturally on this planet, but account for the ultra-dense core of pulsars and the dark, ultra-heavy matter of the galactic halo. It is precisely this third massive strange quark that Brookhaven's particle accelerator is now producing in huge quantities in its collisions. When the cover of atomic nuclei are broken in these collisions, strange quarks are liberated and form a liquid explosive that is boosted by their large energy mass. This formation of strange quarks is called a strangelet and has an enormous attractive power. To put into perspective its huge mass energy, a single spoon of strangelet weighs 1 billion tons. That is 3 times the mass of the entire human population. A strangelet's gargantuan attractive power could suck in an entire planetary mass within a few days. Physicist Franz Wilczek called the explosive conversion of ordinary quark matter into a strangelet an Ice-9 extinction. The term Ice-9 was borrowed from Kurt Vonnegut's satirical book Cat's Cradle, in which an American physicist discovers a similar strange liquid that freezes the planet into ice and extinguishes all planetary life. In the words of Vonnegut's masterpiece, "When I was a much younger man, I began to collect material for a book to be called The Day the World Ended. The book was to be factual. The book was to be an account of what important Americans had done."
In theory, strangelets have the power to devour the Earth. Millions of times heavier than gold, they have a gravitational force so great that nothing can resist it.
Everything that strangelet touches changes into a strangelet. So if you make one in a room, for example, then all the atoms in the room will start falling inwards towards the strangelet, and the strangelet will suck in that matter and grow and get bigger and bigger.
They have finally done it. Brookhaven's collider is now distilling strange liquid explosive, a substance that all the nuclear industry safety reports considered impossible to manufacture on planet Earth. Or, as Frank Wilczek, one of the authors of these safety reports, explains quite cynically, there are no safety measures that could contain an Ice-9 extinction.
I've never been so confident, though, of making a prediction as when I was called to sit on a panel about the possibility of an accelerator turning on and ending the world. Predicting that it won't is very safe, because if your prediction is wrong,
So physicists will go ahead with those experiments, playing a cosmic game of Russian roulette with us all. One might wonder how scientific experiments that seem more like the suicidal actions of a terrorist can be taking place in a country like America, known for its war on terror and paranoia for safety measures. Why would nuclear physicists, a group of seemingly normal human beings backed by all the resources of our society and with the support of our governments, the hype of the press, and the applause of the entire population, move forward with experiments that pose such a clear risk to our lives? The answer is surprisingly simple. We belong to an industrial culture that idolizes the machine as the supreme expression of power and knowledge. In the words of Erich Fromm, a technological civilization is programmed by the principle that something ought to be done if it is technologically possible. If it is possible to make nuclear weapons, they must be built even if they destroy us all. Once this principle is accepted, humanist values are dethroned, and the evolution of the machine becomes the foundation of ethics. So instead of advancing human needs as an ethical society would do, a technological civilization caters first to the needs of machines. And as with any other religion, the technological civilization and its idol, the machine, cannot be questioned or placed into doubt, regardless of the collateral damages it might cause to its human worshippers. In the sacred name of science, believers in technology seem willing to accept risks as necessary sacrifices to achieve the holy grail of future progress. In light of such a collective, fanatic frame of mind, what the news from Brookhaven's collider really means for mankind is that as of the 21st century, the nuclear industry has reached such technological power and efficiency that it can destroy us all, not only with its primary product, the bomb, but also with its particle accelerators. An ice-9 reaction requires only a microscopic critical mass of strange liquid to explode the Earth, and that critical mass is within the reach of our Big Bang machines. We cannot stop the evolution of any branch of science, regardless of its collateral effects on mankind. Strangelets will be created because they represent a technological achievement. The notion that these industries will create any machine simply because it is technologically feasible is difficult to express to most people because we naturally want to believe that our taxes are being used to develop life-enhancing sciences that will benefit mankind. But the nuclear industry has survived every attempt to dismantle it by disguising its negative effects on mankind with a shrewd marketing strategy. On the one hand, in its cynical safety reports, the industry minimizes the danger that the production of strange liquid poses to human life.
Just to say, there is no chance that the LHC presents any danger to the world. It's complete internet nonsense. There's a tiny, minute chance, which would be exciting actually, that you can create these mini black holes.
I have a sort of 0.01% worry that they'll create a real black hole and the entire Earth will disappear in a nanosecond.
On the other hand, it highlights the imaginary benefits of those particle colliders for mankind so that governments will pay for them.
The science world is buzzing about what could be a major discovery.
This particle known as the God particle.
God particle.
It may mean we'd be able to unlock limitless energy. Let me just put it that way. It may be that we would understand the next secret of the universe.
The result of this dual cover-up strategy is a surrealist scenario in which, outside of professional papers, nuclear physicists do not discuss what they primarily produce in their atomic collisions, which is 99% strange liquid, since that is a threat to minimize. Meanwhile, the press, which obeys the same ethics as a technological civilization, disseminates with preposterous hype a litany of impossible theories and magical particles that will supposedly open the doors to heavenly knowledge.
We may discover additional space dimension, the mystery and the origin of the universe.
We may be at the end of the road.
The entire control room is like a group of 6-year-olds whose birthday is next week.
It's incredible that it's happened in my lifetime.
Whatever we learn is going to have a dramatic impact on the way human beings think about the universe forever.
Nothing other than just understanding everything.